All right, and so a rational expression is a quotient of two expressions. So this is a quotient. Remember, quotient means it's like a fraction division. So something to remember from before, that x plus y over y plus x equals 1. So those are the same terms. These are the exact opposites. So technically you can divide out a negative 1 on top, and then that becomes a negative x and a positive y. So that's why these are now the same, and they can cancel, and that's why it gives us the answer of negative 1. So in order to factor here, you're going to need to remember your formula where it says that a cubed minus b cubed equals. So hopefully you remember this. My students, I teach you that it's the SOAP method. So hopefully, so this one here, your a is going to be 4k, and your b equals 1. And you plug it in. And then the bottom, you're going to do your AC method to that one. So when I multiply, that would be, what are your factors of 12 to get 13? So you're going to use negative 12 and negative 1. So I'd have 4k squared minus 12k minus 1k. So this is just reviewing factoring what we did in the other lesson. So factor out your 4k. Factor out your negative 1. Remember, if your third term is negative, you always put one a negative here. So then you write your answer. So since these are the same terms on top and bottom, you can now cancel them. So this right here is your final answer, 16k squared plus 4k plus 1 over k minus 3. So the second answer over here, the factor, I'm just going to pull out the GCF first. So GCF on top is a 12n. The GCF on bottom would be an 18n squared. But you'll see this is a difference of squares now, because 16 is a perfect square and so is n squared. So the top has not changed, but this term right here can factor out further for us into 4 minus n and 4 plus n. And for this reason up here, where I showed how we get a negative 1, these two will cancel with a negative 1 that's left. And then 12 over 18 can reduce to 2 over 3, and this n will cancel with one of those. So we have a 2 over 3, we have the n still on bottom, there's still the negative on top, and then a 4 plus n on bottom. All right, so when we're multiplying and dividing expressions down here, so your first goal when we're multiplying or dividing is you factor everything out. Remember with division, when we get here, you're going to flip your second fraction in order to do it. And so to start factoring right here, factors of negative 24 to get negative 12, make sure you notice it's a negative 24, because some of you might think it's 6 and 4. That does give you 10, but that would not make it negative 24. So to make a negative 24, you're going to use a negative 12 and a positive 2. Factor out the GCF down here. That means greatest common factor. I'm going to factor out my GCF on the top here, which is 5x. And then down here, factors of 48 to get positive 48 to get a negative 16 would be a negative 12 and a negative 4. Once everything's factored, then you get to start canceling. So x minus 12s are the same. You get x plus 2s are the same. These are the same. One of these x's will cancel with one of those. So your final answer is going to be a 5 over x. All right, right here, again, division means that this fraction must flip when we're factoring. So we factor right here, that's going to be the AC method. So I'm going to put it up here. So we're going to have factors of 8 to get 9 would be 8 and 1. So I'm going to have 2s squared plus 8s plus 1s plus 4. And then pull out your GCF. GCF here is just a 1. So the top over here factors into 2s plus 1, s plus 4. The bottom here is a difference of squares, so it's 1 minus 2s and 1 plus 2s. We must flip this fraction, so I'm going to factor the bottom first because that's what will go on top. So factors of 2 to get a negative 3 would be negative 2 and negative 1. So pull out my 2s from here. How did I mess this up? Oh, that's a minus 1 here. Pull out a negative 1 here. So then the top is 2s minus 1 and an s minus 1. Now this goes on the bottom, remember, because we flipped. So factors of a negative 2 to get a negative 1 would be negative 2 and a positive 1. So I'm going to have to factor that down here. So we get 2s squared, let's see, minus a 2, plus 1s minus 1. So I'll pull out my 2s here, pull out my 1. So then I get 2s plus 1, s minus 1. Now I can start canceling everything. So these cancel. Here's the positives will cancel for me. Remember, these are the exact opposites because it's a positive and a negative and a positive. So they cancel, leaving a negative 1 on top. So I have a negative s plus 4 on top and then a 1 plus 2s on bottom. Okay, down here, I'm going to go ahead and just jump to the factored answers on these. If you need to see it, remember it's the AC method. Factors of negative 30 would be a positive 30 and a negative 1. So when you're done factoring, you're going to get 5p minus 1, p plus 6. Down here, same thing. Your factors of 25 would be negative 25 and negative 1. So when you're done, you end up with this. On this one, I'm going to pull out my GCF, which is 3p. This is a difference of squares. Remember that's the plus and minus. So 6 minus p and 6 plus p. Now you can start canceling what's the same. So that's the same. Those are the same. Those are the same. So I end up with 3p over 6 minus p. All right, this one over here is a division problem. So division, remember I need to flip this fraction when I'm factoring. So this right here, the first step would be k squared minus 4 and then k squared plus 4. But remember, this is another difference of squares. So that'd be k plus 2, k minus 2. So k plus 2. And then down here is the AC method again. So when we factored out negative 12 to get that, so we'd have a negative 4k, positive 3k. Put your GCF here. So that gives me 2k plus 3, k minus 2. Flip this. So this is now on top. So I'm going to pull out my GCF for right here. And that's going to be a 6k. Pull out my GCF here, which is 4k. Remember, since this is a plus 4, k squared plus, the plus does not factor. Only negatives is a difference of squares. So when you start factoring, that cancels. The k's will cancel. This becomes a 3 over a 2 when you reduce. So I have a 3 on top and a 2 on bottom, and then just the k plus 2. If you wrote this as this, that would also be correct. Either way is correct right there. Also, you probably can't see. I always forget that that bottom messes up. So you have 3 halves, or you can write it this way. Either way are correct answers on them. All right, on the back, we need to get common denominators here. So common denominator, I'm going to multiply this side by a 5 on top and bottom, and this side by a 4 on top and bottom. So this becomes 15 over 20, 8 over 20. So now I'm just going to do 15 minus 8, gives me 7. Okay, so whenever you see something like this one here, where there's a number, you need to put it over 1. So it's 3 over 1. So the common denominator, we've been multiplying by x plus 4 on top and bottom. So you get 2x minus 1, and then minus 3 times it. So multiplying in my negative 3. Now the bottoms are the same, so I'm going to subtract both of those terms. The negative goes to the 3 and into the 12. So 2x minus 3x, negative 1 minus a negative 12. So that's really plus 12. So you get plus 11. So you have a negative x plus 11 over x plus 4. Now on this one, the easiest way to do it is we're going to have to factor that bottom with a difference of squares. So you're going to have r plus 5 and r minus 5, which means the right side is missing an r plus 5 on top and bottom. And so the top over here will not change. The 6, I'm just going to go ahead and multiply both terms in by the 6. And you're not going to want to cancel here because the whole point, oh, that did cancel for us. That would have been way easier. All right, I'm going to go ahead and do this, and then I'm going to show you what else you could have done to make this problem a lot easier. So then add your like terms on top, you get 7r plus 35. And then at this point, we're going to end up having to factor. So that's why when I saw this right here, I would have stopped. I'm going to show you what I would have done. Because right here, you can pull out a 7, and you get r plus 5. So these cancel. So your final answer needs to be 7 over r minus 5. So as I was factoring here, I should have noticed right away that this and this would have canceled. So what you could have done is 1 over r minus 5 plus 6 over r minus 5. And then look, you jump straight to the 7 over r minus 5, which was a lot quicker than having to do this. Most of the time you have to do this though, but every once in a while you'll get something really nice where it canceled for you. So check for the canceling. Let's see, that's the same problem as that one right there. So let's go down to this here. First, we want to factor to see if it maybe has a common denominator already over here. So factors of 12 to get negative 7 would be q minus 4 and q minus 3. So this side already has a q minus 4, so it just needs the q. That q looks like a g. A q minus 3 on top and bottom. So what happens on top here is that you're going to need to FOIL this term out. So that's going to be, if you FOIL, remember first, outer, inner, last, you get q squared minus 3q plus a q minus 3. I don't know why they keep looking at g, sorry. My handwriting is horrible. All right, so this is a subtraction. So this is subtract like terms. There's no q, so this is a q squared stays. I have a negative 3q, 1q, and then a minus another q. So that gives me negative 3q. Negative 1 minus a negative 1 becomes plus 1, so that makes it a negative 2. And then q minus 3, and then a q minus 4. Factors of negative 2 to get negative 3. You should check to see if it factors. Negative 2 does not give you negative 3. If it was positive, you could. So then this right here would be your final answer. The last type you could get with these are ones that do not at all have anything in common. So this side needs an x plus 6, and then this side needs an x minus 1 on top and bottom. So multiplying your 3 here, so I get 3x minus 3. And then this side, I'm going to have a minus, multiply my 2. A 2x plus 12. Don't forget that negative is going to go to both terms. That's why I put a parenthesis on top so you don't forget. So 3x minus a 2x, negative 3 minus 12. There you go. All right, down to the bottom, complex fraction. So complex fraction is a fraction where you say there's a fraction inside of a fraction. So we're going to treat these as two separate problems. So I'm going to do the top first, get a common denominator, get an answer. Then I'll come back and I'm going to do the bottom. Same thing, and then we'll see what happens. So let's first just do the top part. So to get a common denominator here, I need to multiply this side by a 4, because that would make that 40, and it's missing an r squared. So the top and bottom need r squareds also. So that's 4r squared, and that becomes a 40r squared. So then 4r squared minus 9 is on top. So this factors, so I'm going to go ahead and factor it for us right now because we're probably going to need that later. So it's going to be 2r minus 3 and then 2r plus 3. All right, now we're going to do the whole bottom. So top's done. Let's mark on the bottom. So get a common denominator here. I'm going to multiply this side by 3 and this side by a 2r. Now the bottoms are the same, so you can subtract your tops. So I get 2r minus 3 over 6r. Once you have a fraction over a fraction here, so that's what this is. So really we can just put this right here because it only needed 2 steps. So right now we have a fraction over a fraction. So I'm going to flip the second fraction, that's the bottom one, and multiply. So that's the step I'm doing right here. So the top doesn't change. Now we're going to flip this. So the 6r goes on top, 2r minus 3 goes on bottom. Now we're going to do what we did on the front. These are the same, so let's cancel. This r will cancel with one of those. And then you're going to reduce 6 over 40, so that would give me 3 over 20, and that doesn't reduce anymore. So it'll be 3 and then 2r plus 3 over a 20r. That was a doozy, wasn't it? All right, let's try another one like that one. So this one's a little bit easier here. So the idea here is that to make the bottoms the same, if this is a 6, 3 is a multiple of 6, or 2 is a multiple of 6. So just multiply this by a 3. So I get, so let's add our tops now. I should put an equal sign there. So that's 3y squared plus y squared. Now this factor, so I'm going to go ahead and pull out my y squared because we're probably going to need to do that later. Now let's work on the bottom. Common denominator here would be to multiply this. Remember that 1 is over 1. Any whole number you put over 1 to make it a fraction. So you get 3y over 3y. So add my tops. Now I have a fraction over a fraction here. So I'm going to flip the bottom and multiply it. So it's going to be times, and then flip this. So the 3y goes on top, and then 3y plus 1 goes on bottom. So now these are the same terms. A 6 with a 3 can reduce to a 1 over a 2. So that gives me y cubed over 2, or you can write that as 1/2 y cubed. Either way, those are the same thing. All right, last one here. So this is a 5n and a 10m squared. So I can multiply this by a 2 to turn the 5 into the 10. I need an m squared on this side. And this side's going to need an n. So let's see, that will give me 8n cubed. This gives me n cubed. Oh, there's a plus sign here. So this now is a sum of cubes. That's a cube to cube, and 8 is 2 cubed. 2 times 2 times 2. That gives me 8. So this up on top is going to be using the AB thing, where your A would be 2m and your B is going to be an n. So I'm going to go ahead and factor that. We might not need to, but let's go ahead because it's good practice of practicing our difference and sums of cubes. So that's a plus b, and then it's a squared, so don't forget to square your 4. So a squared minus ab, so multiply them together, plus b squared. All right, now let's do the bottom. So I'm going to multiply this side over here by a 2, because there's no 2. There's one n here and 2 there, so the n's taken care of, and then we're going to multiply by an m. But this is n squared, so this side needs another n. So now they'll both say a 2, an m, and an n squared. So we have 2m over it, and then an n. Oh, yep, that will cancel for us. So I get 2m plus n. So now this fraction is underneath this one right here. So it just took me less steps. So same that we've been doing before. So this right here, we're going to flip the bottom and multiply it. So we have 2m plus 4. Flip this bottom here, 2n squared m. Oh yeah, that's going to cancel some stuff down there too. Oh wait, what have an n there and a 4 here? Oh, this should have been an n. I was just misreading. Plus n. Let's see, what am I doing? Okay, there we go. So this one and this one cancel. So 2 over 10 will reduce to 1 over 5. One of those n's cancels with that. One of those m's cancels with that. So what I'm left with on top is 1n, and then that factor there. And then I'm left with just a 5 and then the m here. And then that's your final answer.